In this video, we're going to do another example of finding a solid using a volume of a solid using cylindrical shells. But in this case, we're going to rotate around a line other than one of the axes. So we've got the region bounded by x equals y squared plus 1 and x equal to 2. And we're going to go about the line y equal to negative 2. So here's a graph of our region. Here's the line y equals negative 2. We could do this with washers. But remember, if we do this with washers, I would have to slice perpendicularly to our axis of rotation. That means since I'm doing perpendicular to the axis of rotation, our axis of rotation is horizontal, I'm really going perpendicular to the x-axis, or that I'm slicing up the x-axis. That means I would be integrated with respect to x, which means I would need to write this thing in terms of functions of x. Since it's already given to me as a function of y, we're going to integrate with respect to y. If we're integrating with respect to y, that means we're slicing the y-axis up. We're parallel to our axis of rotation, which is what's giving us shells. All right. To find the volume of a representative shell, I need to calculate two things. I need its radius and I need its height. The height is probably the easier of the two things in most of these problems, because the height is always going to be, what's the height of this? If you think about this as being a slice, being a rectangle, it's what's the height of the rectangle. It's going to be the difference of the curves. I do right curve minus left curve. The right curve is 2. The left curve is y squared plus 1. So this quantity here is what's giving me the height of the shell. The radius is the one that's usually a little bit trickier to think about. It's not bad, it's just usually a little bit trickier, because you're used to doing right minus left or top minus bottom for finding areas between two curves. So that's why I think it's a little easier to see what the height is versus what the radius is. All right, what about the radius? So radius is going to be distance from the slice to the axis of rotation. Well, in this case, your slice is at a height of y, because the y is changing. So the only thing I can do is represent it as a y. So we're going to go from y to negative 2. Well, the difference between those two things is the distance, so that's why we get y plus 2 as our radius. Okay, so again, the slice is at a height of y. The axis of rotation is a height of negative 2. Y minus a minus 2 is the radius. So it's always, your radius for shells is always going to have the form variable minus number, or number minus variable, depending on which one's on top and which one's on the bottom. In this case, the y is above the negative 2, which is why we've got y minus a minus 2. If your y were down here, you would do negative 2 minus y. All right, so now we've got 2 pi times the radius, which is y plus 2, times the height, which is 2 minus the quantity y squared plus 1. We also need our limits of integration, which are y's. So again, we set the two curves equal to each other and solve. We'll get y is plus or minus 1. So that's where our limits of integration come from. Multiplying out your integrand gives you 2 plus y minus 2y squared minus y cubed. Find our antiderivative here of 2y plus y 1/2 y squared minus 2/3 y to the third minus 1/4 y to the fourth. Plug in your endpoints and subtract using your fundamental theorem of calculus. Don't forget to multiply by your 2 pi out in front and get a final answer of 16 pi over 3.